Hello everyone. So if you want to have some context on what we're doing right now, make sure you watch the video from week 1. So for this video, we're going to apply all the things that we learned in the previous video and use a tool to actually do some preliminary exploration of some data. So I prepared an example data set, and then we're going to explore if the data set has qualitative data, quantitative data, and maybe try converting some of those data types from qualitative to quantitative, quantitative to qualitative. So what you're looking at right now, if you're unfamiliar, you're looking at Google Sheets. So Google Sheets is one of the spreadsheet applications that I talked about in the last video as well. So there are other spreadsheet applications, admittedly more powerful than Google Sheets, like Microsoft Excel, for example, but since that's not free software and we can do everything that we need to do in Google Sheets, we might as well stick with Google Sheets. So we're gonna talk about other tools in the future discussions, but for this specific topic, we're gonna stay in Google Sheets for now. Okay, so I'm going to start by importing the dataset that I prepared for this. So the dataset that I prepared for this, sorry about that, let me find it here. It should be called coffeesales.csv. Let me make it bigger so that you see everything. This one right here. So a .csv file is what is known as a comma separated value file. So if you open this one, different ways you can open this would be through a text editor like Notepad, for example. You would see that this is simply containing some text separated by commas, and every line of this .csv file corresponds to a row in a tabular data set. So the first line right here refers to the header row. The second line right here refers to the first proper row, and each row right here is separated by commas. So you have here 10, comma card, comma 38.7, and so on. So it's hard to navigate data like this, and it's just written in text. It's hard to apply changes to it as well. So what we're going to do, we're going to load this in our spreadsheet file. So let me close this for now and go back to my Google Sheets right now. So this is just a new spreadsheet. So you can go back, for example, create a blank spreadsheet like the one I just had. Let me increase the zoom so that it's easier to see what I'm doing. Okay, so to load that .csv file into my Google Sheets right here, I'm going to select File, go to Import, and then since that is stored in my own computer, I'm going to go to the Upload tab right here. I can either drag that file from here or browse, since I know it's stored in my Downloads folder. So that's called coffee_sales.csv. Open this one right here. And Google Sheets is going to process this data for us. So since it sees that this is a .csv file, it knows that the values are separated by commas. So it will be able to detect automatically that it's separated by commas and is able to process that by itself. But you can also explicitly state what the separators for the values are. So in case you have a .tsv, for example, that would be separated by tabs, or it could have other separators. But most of the time, you're going to have a .csv or comma separated value file. So it's going to be able to detect that those are commas. So I'm going to leave it as detect automatically. And I'm going to insert a new sheet, for example, right here, so that in case you're working in this current sheet one, it won't replace the current values in the cells that you currently have right now. So right now it's empty, so it doesn't really matter. But I'm gonna go import this data right here. The text box right here will also convert the text value into numerical values, date values, and so on. So you leave that checked. So now that we've loaded our data set right here, we have every single line in that .csv file has been converted into a separate row in our spreadsheet. And you have the columns as well right here, and it comes with headers, which are the names for the columns, or in the context of our data, our tabular data, this would be the names of our features. So what you're looking at right now is the data set concerning the sales in a coffee shop. That's why it's called the coffee_sales dataset. So I'm just going to explain what each of the features would mean. So when you download a dataset from the internet, for example, or if you collect a dataset by yourselves, you would happen to have explanations on what each of these column names mean, because you're not usually going to write the entire description of that column, because that would be too long. So for example, you're just going to write a short name for that one. Hour of day, for example, would refer to which hour of the day this coffee sale occurred. So there was a customer at 10 a.m. and then the type that this person used would be card, and then the money, the amount that they paid for this specific coffee would be this amount, 38.7, and then the name for that product right there. So they're only selling coffee, or either they're only tracking coffee sales, so latte, hot chocolate, etc. The time of day, so this is just a variable that describes if the sale happened in the morning, in the afternoon, or in the night. Weekday, it just describes if this sale happened on Monday, Tuesday, Wednesday, etc. So this one is on a Friday, and then the month name, March, so shortened to MAR right here, MAR. And then weekday sort, this is just a numerical, a qualitative conversion of this weekday right here. So Friday would be converted to the numerical value 5, Saturday would be converted to the numerical value 6, and so on. Month sort, which is the same as well, the numerical conversion of the month. March is the third month in the calendar, so the month sort for that one would be 3. But they also recorded the actual date as well. So in the following format, 2024 3/1. So this sale happened in March 1, 2024, and then the specific time for that sale. So every row here would correspond to a single sample, and for the context of this data set, a single sample corresponds to one coffee sale, one transaction. So let's start by processing this data set with some of the skills that some of the concepts that we described in the last video. So the first thing that we're going to do, since this data set doesn't have an index, we're gonna add an index for this data set. So an index, again, if you want some more context on what an index is, you can go back to the video from the last meeting. But briefly, it basically is a unique identifier for each sample in your data set. So a unique sample also has a unique data set as well, a unique index as well. So to do that, I'm just going to insert a new column right here to the left of this first column. So I'm going to select this one, insert one column left. And then you can name this as index, for example, or you can use any name, but as much as possible, you want your column names to be as descriptive as possible, but at the same time short as well. So index is an okay name, but if you want to specifically describe, for example, what your sales refer to. Sorry, I have some issues with the internet. This is one of the issues with Google Sheets, since it is an online spreadsheet, or it's a web-based and at the same time online spreadsheet application. You do need internet access to use it. Okay, I think I'm back. So index right here can be renamed to something more descriptive, something that describes one sample in your data set. So our one sample in our data set describes a coffee sale. So I can write sales index, for example, just to give whoever is reading this data set an idea on what a sample would refer to. So since I know that this refers to sales, I'm going to write and call it sales index. And you want the index to be unique for each sample that you have. So for example, one thing that you cannot do, if this is indexed at 1, you can't call this index 1 as well, because they won't have unique identifiers. So since these two rows right here correspond to two different sales, so they must have different indices as well. So one easy way that you can do for this one would be to name this 2, 3, and so on. But if you're gonna do this manually, you're gonna take a long time, since if you look at the number of rows or the number of samples in your data set, there's a lot. So one of the cool things with spreadsheet applications is that you can automate a lot of those tasks. So in Google Sheets, for example, you can just select what you've already written right here and then drag this downwards, and Google Sheets is going to figure out what you're doing right here and what the pattern is and extend that pattern. I got disconnected again, my LAN cable. Okay, so while waiting right there, there you go. So you can again drag this one right here and then drag this to the end of your data set, so that all of them will be numbered uniquely. So this is a proper way of indexing your data set, since two rows are guaranteed to have different indices. Another way of doing this would be to write, for example, using formulas as well. I can use the formula row for this one, and to insert a formula in Google Sheets right here in a cell, it must start with the equals character, the equals symbol, and then write the formula name. The formula name for this one will be row, and then press tab to accept, and then B2. So what this formula does, row B2, it is going to find the row number of this cell. So this cell right here is in row 2. So row B2 right here will evaluate into the value 2 as well. So I can do this for all of my samples. So it's a little bit different since I start with 2 instead of starting with 1. So it would be more proper to start with 1. It would just make more sense to start with 1. But this is still a valid way of indexing your data set, since the indices will stay unique like this. So it doesn't matter if you start with 2. As long as the indices are unique, and that's a valid way of indexing, because the exact value of an index doesn't really matter. You just want your indices to be unique. Indices don't even have to be numerical values, but numerical values are just the easiest way to make unique values out of, because there are a lot of unique numbers out there, and that's why we're using numerical values for this one. But if you really want this one to start at 1, for example, I can just subtract 1 from the current value that I have. So the 2 subtracted with 1, so that the value I'm going to get is 1. I'm going to extend this up until my last the last sample in my dataset. So I'm going to copy just one of them. I'm going to select all of the empty rows, all of the cells that I haven't added an index for. So up until this last one right here. So what I did right now is just shift select, because I can't drag everything, because my screen is not enough to show all 3,548 rows of this one. So apparently this is going to happen regularly for this video, so please bear with me if the internet connects and if the internet disconnects and I have to pause what I'm doing every now and then. Anyway, so I'm just gonna paste that formula for all of the cells here. So I just pressed Ctrl C and Ctrl V. So just to break that down, in case you're not familiar with shortcuts like those. So copy this one, right, and then select everything. Starting from this one, I'm gonna press this with my mouse, select that one, and scroll down up to the last row. Hold Shift and press this row right here so that all of these cells are selected, and then right click, paste. So Google Docs or Google Sheets will tell me I have to use the shortcuts for this one. So the shortcut for that one would be paste, Control V. So I get all of my indices, my unique indices generated for me. So now that I have my indices, the next thing I'm going to do is to convert this data set right now. This is just a raw spreadsheet. So I want this to be formatted as a table because it will make it a lot easier for me to reference the columns in this table, to reference the samples in this table, and so on. So you'll see some why we're doing this formatting right here later when I do some more formulas. But for now, let's do that. So I'm going to select all cells that are relevant in my data set, including the headers. So starting from this cell right here up until the last cell at the lower right, at the bottom right. So this selects the entire table, so I still use the shift click method right there. Now that that's selected, I'm going to go for format and then convert to table. You can also use Ctrl-Alt-T to convert a table using this shortcut. So there you go. So all that did is created this table called table 1 right now, and this converted them. These headers right here in my row 1 are now converted into column names, or in the context of our data set, you can call them feature names, for example. I'm also going to rename this auto-generated name right here. So to make it more descriptive, I'm going to call this dataset, for example. There you go. Okay, so let's explore this dataset. I'm going to go to this previous sheet right here, and this is the sheet where I'm going to write the information of this dataset right here. So what we're doing right now is the early stages of what is known as exploratory data analysis or data preparation. It has a lot of names, but it's one of the first stages that you're going to do after you've collected your data, the first stages of data analytics. We're gonna talk more in depth about that specific stage of analytics, but for now, we're gonna do some basic stuff to remember the concepts that we learned in the last video. Okay, so I want to know how many rows are in my data set. So right here, number of samples. I also want to know the number of features in my data set. So I'm just going to collect some information about it. I want to know which values or which features are qualitative features. I also want to know which features are quantitative. So I'm going to make this bold right here, Control B. So how many samples are in my data set? One thing you can do for that one would be to simply scroll down and then see that the last row is number 3548. So assuming that there are no duplicate rows, then I would have 3548 minus 1 samples in my data set. Minus 1 because the first row is dedicated for the header row. So we don't include this row right here as a sample, since these are just names for your columns, so we're not going to count that one. So 3548 minus 3000, minus 1, which is 3547. So you can write that here, 3547, for example. But you can also figure this out using a formula, so that you don't have to scroll all the way down to the last sample, in case that you have a really long data set, you have so many samples. By the way, I'm just going to rename this sheet right here, so keep your eyes on the lower left section of your screen. So this one, I will rename this as information, which refers to the information of this data set right here. So the number of samples right here, we can find this using a formula, equals, and then I'm going to write the formula rows. So this is not the same formula that we used earlier. That formula was called row. This one right here will be called rows, which will calculate for us the number of rows in this data set. So I will write data set. I can even select it from here, since it knows that one of the tables that exist in this spreadsheet is called dataset. So this is an advantage of creating or converting this spreadsheet right here into a table. I can now reference those names for my formula. So the number of rows in my dataset would be 3547. So this value again doesn't include the header row, so it already subtracted 1 for that one. It doesn't count the header row. So this is the correct amount. So the next thing I'm going to do, I'm going to count the number of features. So the features of a tabular data set would refer to the columns, not including the index. So you can just simply count how many of these are there. So this is a feature, this is a feature, and so on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So there are 11. But you can also figure this out automatically using a formula as well. You can use equals. So columns, which would refer to the number of columns in our data set. So I'm going to enter the name of the table. Number of columns in my data set would be 12, but this one includes the index. So I don't want to include the index right here, because an index is not a feature, it's just, again, a unique identifier for my samples. So I can subtract 1 from this one as soon as I connect back to the internet. So to edit this current formula right here, I can double click this cell. I can also edit it in the formula section right here. Oh, my internet was okay a while ago. Now of all times, it's going to have problems when I actually need to use it. There you go, -1. So there are 11 features right here. So while we're here, I'm going to rename this, by the way, so that this doesn't stay as untitled spreadsheet in my drive. I'm going to rename this with a descriptive name as well. So this would be the coffee sales dataset. So I'm just going to copy the formatting of how they named it. They didn't use spaces, they used underscores for their names. So I'm going to do the same as well. Okay, so what are the qualitative features in this dataset? So you can just look at these one by one. And hour of day, for example, these are numeric values that make sense when you add them together. So hour of day is a qualitative feature. So I can write here hour of day, for example. Cash type is not, money is a qualitative feature. It describes some form of, sorry, not a qualitative, quantitative. I always mistake these two together because they just have similar names. Let's start with qualitative first. Sorry, that's my bad. So this one is qualitative, so quantitative, sorry, this one, hour of day. Cash type is qualitative. It describes if the type of payment that they used is cash or card, for example. So card type is qualitative. So I'm going to include that here, card underscore type. This one is not, coffee name is qualitative. This describes what type of coffee they bought in the transaction. Like that. And so on. So you're going to do this for all of the qualitative features. But you can also, instead of typing the names manually, you can use a formula for this one as well. You can just write equals, and then go back to my previous sheet and just select the header that contains the name of that feature. So cash type right here. And then press enter. So I end up with this one. So we're going to end up with the same result, but the advantage of this one will be when you rename this row right here. That will be reflected. That change will be reflected as well here. So anytime there are changes in this data set right here, this will also change. So that's an advantage of using formulas, for example. So let me put the name back to cash underscore type, just so that I'm using the same formatting for everything. So it goes back to cash underscore type as well. So I'm going to do the same process for all qualitative features as well. So another qualitative feature would be coffee name. Press enter. Equals again for this one. Time of day is qualitative. Enter. Another qualitative feature would be weekday. It doesn't make sense for you to add Friday plus Friday plus Friday, for example. That's not a numeric value. Press enter. Equals month name, March plus March, March minus February. It doesn't make sense right now, so that is qualitative as well. This one, weekday sort is quantitative, month sort is quantitative, date and time are qualitative as well. So date, I think I have one more, time. So I'm going to insert another row above this one so that I have space for the last qualitative feature available to me, time. So equals time, press enter for this one. So I'm going to remove the bold formatting for this one, just to make it the same for everything. Okay, so these are my qualitative features. My quantitative features, I'm going to do the same as well. Equals, so that's hour of day, money, and weekday sort, month sort as well, and that's it. So again, there are 4 quantitative features and 7 qualitative features. Okay, so the next thing I'm going to do, I'm going to count how many unique values are in my qualitative features. So for example, for cash type, how many possible cash types are there? So card, cash, or whatever payment type they used for that one. So what you can do, you can just look at all of your rows, all of your samples, and count them one by one. But of course, that's gonna take a long time if you have a lot of data. So it's better to use a formula for that one. What you can do is you can use the count unique formula. So if you read the description of this formula right here, it counts the number of unique values in a range. So let's use that one, count unique. And then we're going to enter here a range of values. And since we already have column names because we formatted our spreadsheet into a table, I can just write here dataset and then cache type. Then press enter for this one. Sorry. Oh, I misspelled the name of the table, so if you do some typographic errors right here, so it won't display a value. So to fix that one, just fix the error. So these are the number of unique values for cache type. So that basically tells us that they only recorded the card payments. They didn't record the cash payments, for example. Or maybe this coffee shop only accepts card for payment. So these are the number of unique values for that one. So let me create a column for this one. Number of unique values. So, or number of uniques, just to make it short. So coffee name, how many unique values are there? This would basically tell us how many coffee types or how many coffee products are they gonna sell? Are they selling? So I'm gonna do the same formula. So equals count unique. So it doesn't matter, by the way, if you use all caps or not all caps when you're writing the formula name or the function name of the formula. It will still work. You just have to write with the correct spelling. So count unique, again from our table dataset, specifically the column coffee name. And there are 8 coffee types that they're selling. How many possible time of days are there? Right now I see 3, morning, afternoon, and night. Let's see if that's all 3 of them or there are more down there at the bottom. So using the same function, count unique from the data set or from the table named dataset, specifically the column time of day. So the suggestions right here will also actually tell us what are the possible values. I can just navigate using arrow keys up or down, and then to select that one, press the tab key. It will automatically enter that for you. You don't have to write everything. It will auto suggest. Weekday, how many weekdays are there? I should be expecting 7 for this one, unless they don't have sales on weekdays or some weekends, for example. So let's see if they do have sales on all days of the week. So count unique, tab, and then dataset. I'm gonna select right here weekday, press tab, close parenthesis to finish the formula, press enter. There's 7. So to make it quick for me, I'm just going to copy the entire formula right here. I'm going to paste it here and just replace this one right here with the column name that I need. So I need the column month name. So they have sales for all 12 of the 12 months. Date. How many unique dates do they have sales in? So for all 381 unique days, they have sales for each of them. And then this doesn't really give a specific insight because dataset time. So how many unique times of day are there? So there are 3,600. No, that doesn't make sense for this one. So yeah, the number doesn't really help us with a specific insight right now. But this will basically count again the number of unique time of days or times. So what we can also do for quantitative features, we can check the range of values, the minimum value, the maximum value, and the average value for that specific feature. So the min will refer to the minimum, the smallest value of all possible values that you can find in a dataset. The max is the largest value for all possible values you can find in a dataset. And the average is simply the average value. Okay, so we can use formulas for this one as well. So you can just use the min formula, the minimum value in a numeric data set. Exactly what we need. And then just write the column name that we need right here. So data set, specifically from the column, hour of day. Tab, we get 6. So I guess they don't have sales before 6 a.m. The max, I can just copy this one, formula, to make it quicker for me. And instead of using min, we're going to use the max function. So 22. So it would refer to 10 p.m. So they have sales from 6 a.m. to 10 p.m. Money, the minimum would refer to the smallest value transaction or the cheapest coffee that they have, probably. So let me copy this formula right here and just change the column name. So the column money from our table data set. So this is the smallest money value from all of the possible transactions in the data set. So this one, I need the max from money as well. There you go. So the min for this feature, just need to replace this with weekday sort. So I should expect this to be 1, which would refer to Monday because they have sales in all 7 days of the week. It's just an autofill for me, but I need to change this one from month sort. So they have sales in January. So 1 refers to, again, the value Monday, and 1 refers to the value January. So let's copy this one, but replace this with max to find the max value in this column. Oops, sorry. When you're editing this one, by the way, you need to press enter to finish the changes. So min should be changed to max and then enter. There you go, 7. And for this one, copy the formula from this cell and paste it in this cell and replace the function from min to max. So the max month value, so press enter. I can just click anywhere else. Then 12. So they have sales from January to December. So for the average values as well, you can use the formula average for this one. Average, and you just enter a range as well. So the average for the column hour of day, you can just again enter it here. Data set hour of day as well. So this is the average hour. Let me copy this one and then paste all of these values right here, so that I can just need to change all of these formula names into average. This is the average cost for all of the transactions, 31. This is the average weekday sort value, so 3.8. This one is the average month sort value, which would be 6.453904, etc. Okay, so just by doing these, we get a lot of insights in our data set. So this is just, again, very preliminary data exploration. So we already have our data collected for us. What we did right now is to explore the data. And just by doing that, we do get some insights. Some insights that we get, for example, is that they have sales for all days of the week. They have sales from 6 a.m. to 10 p.m. and etc. So we can get more insights from exploration. the more tools that we learn. Okay, the next thing we're gonna do, we're gonna try to convert some data, some features from qualitative to quantitative or from quantitative to qualitative. So for the current data set that you have right now, you have some conversions already prepared for you. So for example, weekday is already converted into quantitative data. The conversion is called weekday sort. So Friday corresponds to the 5th day of the week, Friday corresponds to the 5th day of the week, Saturday corresponds to the 6th day of the week, Sunday corresponds to the 7th day of the week. So this is an example of encoding your qualitative data that is ordinal into numeric. So since weekday is ordinal qualitative data, we can just replace them with values from 1 to 7, for example. That's exactly what they did right here. And that's exactly what they did for month name as well. March is the 3rd month in the calendar. April is the 4th month in the calendar, and so on. So that's some conversions that you can do, that they already did. Let's say we're gonna do our own conversions. So time of day right now doesn't have a conversion, even though they already have an hour of day, which is a more specified version of a time of day. So just for the sake of learning, let's ignore that this column right here exists, and then let's just say that we want to convert our time of day into a specific numerical value. And if you notice time of day right here, it is qualitative and at the same time it is ordinal. There is an inherent ordering of the time of day, ordered depending on how early the time of day is. So morning is the earliest, afternoon is the next earliest, and night is the latest. So there's an inherent ordering. So we can convert them into numerical values directly. We don't have to convert them into dummy values, for example. So let's start doing that. So what I'm going to do, I'm going to add a new sheet right here. Or I can just do it here, actually. I can just stay in the information side. So I'm going to create an encoding, or what is known as a lookup table as well. So I'm just gonna write here, these are the time of day values. These are all of the possible values the time of day feature could have. Right now there are 3, morning, afternoon, and night. And then I need to find a way to encode them, or the encoding. There you go. So I can make here morning, afternoon, and night. And then encode this as 1, 2, or 3, for example. And this is an encoding table. We're gonna use this table right here to create a new column and create an encoding for our time of day column to convert this one into quantitative values. But there's also another way of doing this. You can do this using formulas as well, because if you just manually write morning, afternoon, and night, what if you have a lot of different possible time values? What if you have a lot of unique values for these features? Then you're gonna have to enter every single one manually. Right now it's easy because there's 3, but what if there's 1,000, for example? That's not out of the ordinary. So to do this using formulas, you can use the function unique. So this is equals unique. So if you read this one, the unique rows in the provided source range. So we're going to give it a source range, which would refer to our column dataset, from the table dataset, column time of day. There you go. So this will basically generate all of the unique values. So the formula way of doing this is again faster, and at the same time it also helps if you have changes in your dataset. For example, let's say you add new sales entries, samples in our dataset, then that will also be reflected here. It's going to automatically add a new value as well. For example, if we replace this one with dawn, for example, or dawn, then automatically it's added right there. Dawn is one of the default or one of the unique values in that row. So that's again an advantage of doing it using formulas. So let me back to the original value, which is morning. So it reverted to the original one. So these are the encodings I want. Again, the encoding, it will be up to you how you encode it. As long as you preserve the ordering, you can order them as 0, 1, and 2, for example. That's a valid encoding because the encoding is ordered in the same way as how early these values are. You can use -1, 0, or 1, for example, because it's ordered in the same way as well. Again, as long as it's valid ordering. So for me, this makes a lot of sense. So I'm just going to keep it as 1, 2, and 3, for example. Next thing I'm going to do, I'm going to convert this into a table so that it's easy for me to look up from this table. So again, go to Format, Convert to Table. I'm going to rename this table as Time of Day Encodings. There you go. So whenever I want to refer this table right here, I can just use the name Time of Day Encoding. There we go. But the name is quite long, it doesn't fit right here. Maybe I adjust this one. There we go. Okay, so now that we have the encoding table, we're now ready to add a new column right here. I can name this, for example, Time of Day Quantitative. So that's a little bit too long, so I'm just going to shorten it to Time of Day Quant. Leave this as capital D so that it's the same way it's written from this column, Time of capital D Day. So that's Time of Day Quantitative. Okay, so to automatically generate the conversion of this value into this value, we can use formulas as well. Let me hide some of these columns that we don't want to look at right now, so it's easier to see everything. I'm just gonna select these columns from column G until column L and select hide columns G to L. There we go. So that this column and its qualitative conversion is right next to each other. So the function I'm going to use is a very powerful function that you might end up using a lot, called VLOOKUP, also known as vertical lookup. So I'm just going to write down the formula right now and I'm going to explain what it's doing. So VLOOKUP, and then it's going to look up values from here, and then from the table Time of Day Encodings right here, and index 2, and then false. There you go. Suggested autofill, so it will automatically generate an autofill for me. I'm just gonna say yes to that. Okay, so let's explain what it's doing, this formula. So the VLOOKUP formula stands for, again, vertical lookup. So we're gonna provide it with 4 different values in the function. F2 right here, the first value. This is what we're trying to, the values we're looking for. We're looking for morning in this encoding table right here. So whatever is in F2. Let's wait for this to connect back. There we go. we're looking for whatever is written in cell F2 in the table time of day encodings. So cell F2 would just refer to, please connect back. So cell F2 would just refer to whatever is highlighted right here, but you know that this is cell F2 because this one is labeled right here, column F at row 2 of the spreadsheet. And then where are you looking for this value? We're looking for this value in this table called time of day encodings. So since we named this table time of day encodings, we're going to use that name right here. And then 2 right here will refer to the index or the offset index. So again, it's going to look for morning in this table. So morning in this table is this one. And then we're going to look at the second value to the right of this morning cell. So to the right of this morning, the second value is this one, 1. So we end up with the value 1 right now. And then the false right here is just a flag for that is sorted value. So because we're not looking for a sorted list of values, this works for the numerical conversion from qualitative to quantitative, but we're converting from, sorry, this only works, this flag right here, this false flag right here will work for conversions for quantitative to qualitative, but what we're doing right now is qualitative to quantitative, so we're going to keep this one false. I'm going to explain more what that does later. So again, just to repeat, let's look at this formula right here. So it is going to look up whatever is in F3, which is afternoon, in my table time of day values. So it has found afternoon here, and it's going to move to index 2 to the right of it. So afternoon, then this one, whatever value is here, it will be reflected in the cell. So that's why we got 2 in this case. So for this one, look up whatever is in F23. In this case, we have night. We look for night in the table time of day encodings, and whatever is to the right of that, 2 spaces to the right. That's why we write 2 right here. 2 spaces to the right, that's 3. So what is reflected in this cell would be 3. So we're going to do the same for everything right here. So just the only difference between this cell and this cell is what it's looking for. It's looking for the value written in F3. This one is looking for the value written in F4. This one is looking for the value written in F5, and so on for all cells in this column. So this will automatically convert your time of day qualitative variable into time of day quantitative variable. And one thing that we can do, since this is now quantitative, we can now add this in our list of quantitative features, for example. So to do that, we can then write here equals, then go back here just to select the cell, time of day, and press enter. And then I can find the min, max, and average value for these. So the minimum value in our time of day quantitative, the minimum value in our time of day maximum value, sorry. There you go. And then the average value in our time of day quant as well. Underscore quant. There you go. So we get some insights right here. So the earliest time of day is morning, the latest time of day is 3, and then the average is somewhere around 2. Okay. Let's try converting the other way around. Let's say we want to convert money from quantitative to qualitative. So the context for this, why we might want to convert quantitative to qualitative. So can go back to the previous video and why we might need to do this. So to do this one, we're just going to use the VLOOKUP table as well, but we're going to build a lookup table again, but it's going to look a little bit different in this case. So I'm going to call this the money bins, and then the bin name. Okay, so we already know what the smallest possible value there is, 18.12, and then the largest possible value is 38.7. So again, it will be up to you how many bins you're gonna create for your conversion from quantitative to qualitative. Let's say I want 5 bins in my case. So I want everything more than 18, everything more than 22, everything more than 26, everything more than 20 for 30, everything more than 34, and my largest value is 38. So everything more than, sorry, let me rephrase this one. Start with 18 plus 8, 26 plus 8, 30, 9 for example. Let's change this one to 28. Oh, let me go back to the previous one. Let's say I need 5 bins. Sorry, ignore everything that I just did right now. 18, 22, 26, 32, 30, 23 plus 5, 28 plus 5, 33, 39. Okay, sorry. Actually, the previous one was correct. Sorry, I keep changing. I'll explain what I'm doing right now. 36. Okay. Now call this bin right here cheap. So these are basically descriptions of how expensive the transaction is, or the coffee sale is. I'll call this one, actually I'm going to change this one to very cheap. Okay, change this one to cheap, and then this one would be fair, then this one would be expensive, this one I'm going to call this very expensive. So again, so just to explain what I did for these numberings right here. So when you're creating bins, you need to create ranges for values. So everything that is from 22 to 18 will be very cheap. Everything that is between 26 to 22 is cheap. Everything that is 32 and 26 is considered fairly priced. Everything that is between 36 and 22 is expensive. And everything that is more expensive than 36 is very expensive. So this is just what the lookup table looks like. Okay, so next thing I'm going to do is I'm going to convert this into a table using format, convert table again, rename this one to money encodings, or money encodings, like that. There you go. And to use this, I'm going to create a new column right here. I'm going to call this money underscore qual, or the qualitative conversion of the money feature. It's lowercase m, so just to keep it uniform, I'm going to use lowercase m for this one. Let me hide all of these unnecessary ones again so that these two columns are side by side. There you go. So I'm going to use the VLOOKUP table as well to generate this. So VLOOKUP, I'm going to search for this value in my lookup table, and the lookup table is named money encodings. And I need an index. I'm going to use 2 as well for this one, but here I'm going to write true for is sorted. Okay, so let's break down what is going on right here with the VLOOKUP formula. So the VLOOKUP, again, it's going to look for whatever is in D2 inside our money encodings variable, inside our money encodings table. So it's going to look for 38.7 in our money encodings. So 38.7 doesn't exist, but what it's going to do, it's going to look for the closest value that is not greater than 38.7. So the closest value that is not greater than 38.7 is 36. And since 36 is assigned in the very expensive range, it's going to write very expensive here. Another example, it's again going to look up whatever is in D5, which happens to be 28.9 in our table money encodings. So 28.9 doesn't exactly exist in this table right here, but we're going to look for the closest value to 28.9 that doesn't exceed 28.9. So that value is not 32 because 32 is greater than 28.9. So the closest value is 26. And it's going to write index 2. So to the right of that, that's fair. So the value encoded is fair in this case. Another example, let's say 24. So 24 right here, we're searching for a value 24. That is what is in D88. It happens to be 24, and we're looking for 24 in the table money encodings. So 24 doesn't exist again, so we're going to look for the closest value that doesn't exceed 24, so that's 22. So that's cheap in this case. So the reason why we wrote true for this one and false for the other one is this is the is sorted tag. This will only work if you write true right here, because this has to be sorted from least to greatest, and this is a conversion from quantitative to qualitative. And now that we have this one, we can add one more qualitative value right here. I'm going to insert one row below. There you go. So I have space to write my new column called money qual, and I'm going to count the number of unique values right there. So that's equal to unique from the table dataset, and specifically from the column money qual. Oops, sorry, I might have misspelled something. Sorry, not the unique variable, count uniques. Unique will generate the unique values. There you go. So there are 5 uniques, and that would be very cheap, cheap, fair, expensive, and very expensive. And we can also again count how many values are considered very cheap, how many values are considered cheap, how many values are considered fair, expensive, very expensive, and so on. So to do that, we can use equals count. You can use the COUNTIF function for this one. And what it does is it will count the number of values if it passes a specific condition. So I'm gonna write here the range for this one, we're gonna count from the column Dataset money qual, and the criterion for this one is that it must be equal to whatever is written right here. There you go. Gonna autofill this one. Okay, so just to break down what's going on right here, the COUNTIF function will count all of the values that satisfy this criterion in the range dataset money qual. So in this column right here, it's gonna count how many values are equal to whatever is in B28, which is very cheap. How many values are marked very cheap in this column right here, and that happens to be 95. So another example, 1555. So COUNTIF as well. How many values are equal to expensive? So that's what's in B31 in this column right here. How many values are expensive in this range? That number is 1555. And this will basically give us some insights that most of the sales would be in the expensive coffee. They actually don't get any sales in the very cheap coffee. So this is useful insight on what sells in this specific coffee shop, for example. Gonna write count for this one, and you can even use this one as data for your chart. So this is a little bit advanced because this is visualization. We're gonna talk more about this in future videos, but just to show what you can do with this insight, you can show a chart for this one. Insert chart. Basically tell you let me redo that. I need the names for these as well. Insert chart. There you go. And this will give you a breakdown of how many sales are they getting in the very cheap coffee products, how many sales are they getting in the cheap coffee products, how many sales are they getting in the fair coffee products, and so on. And we can see that the expensive coffee products get the most sales, for example. And okay, that's it. So you're gonna do something similar for the assignment, the first assignment that you're gonna do, but you're gonna be using a different data set for that one. I'm gonna provide a different data set for you. So hopefully you watch this video and you try to follow along as well. If not, you can just look back at this one. I will also post this exact data set as well as an example of what you're gonna do. And all of the formulas right here will be preserved, so you can use this as a guide on what you're gonna do for your assignment. And that's it, everyone. Thanks.